All right, so I'm going to talk to you for a minute about multiplying polynomials. This can get a little bit trickier than the adding or subtracting, but not too bad. We should be able to handle it, no problem. So you have probably multiplied two binomials together before, which is binomial means that it has two terms. So let me just write 2 here. Now, a lot of you have probably learned the term FOIL, first, outside, inner, last. I tend not to use that too much because that only applies when both of them are binomials. I kind of prefer to think about distributing over FOILing, and I'll show you why, and it'll make more sense in just a minute. But as we work through this one, what I want to do is I want to start with the first term in the first parentheses. And important to remember that if there's more than two parentheses here, I never want to work with more than two at a time, okay? I want to stick to just two at a time. So start with your first parentheses, circle the first term. This first term is going to distribute to every term in the second set of parentheses. Now, before we multiply these, let me just review you for a minute. When we multiply terms, okay, so in other words, we'll do this x times 3x. What we want to do when we multiply is we multiply the coefficients, and remember coefficients is a big word for the number in front of the variable. We want to multiply the coefficients, and then what we want to do is add those exponents together. Okay, and even though it looks like there are no exponents there, remember, if there's no exponent, there's an imaginary 1. So when I multiply these two things together, and again, imaginary 1 sits here, or an implied 1, I want to multiply the 1 and the 3 together, and I want to add those exponents. So 1 and 1 would be 2. So x times 3x is 3x squared. Now, as I work through this, again, that's 3x squared. This is then going to distribute here, and watch these signs. So then I have minus 4x. Now again, I'm done with this one, so I'm going to mark it out, and I'm going to move on to the next term. Circle it, this is a 2, and I'm going to distribute it to everything in the second parentheses again. 2 times 3x is 6x, and 2 times negative 4 is negative 8. Okay, so all I need to do now, and if there was a third term in that parentheses, then I'd go ahead and circle that one, and I'd push that one on through also. But since there's not, and I'm done, I want to clean it up a little bit, and to clean it up a little bit, I'm just going to combine my like terms. Remember, if you don't remember what like terms are, they have the same base and exponent. There's an implied 1 here on these exponents. So 3x squared, there are no other squared, so I write it, but I do have a negative 4x and a positive 6x, so I'm going to combine those to 2x minus 8, and I'm done with that one. I do want to show you one that's a little bit longer, just in case you get stuck on one like that. Maybe I have x squared plus 3x minus 1, and I want to multiply that to 2x squared plus 5x minus 3. And so what I want to do is the same process. I start with the first term, and I distribute through x squared times 2x squared. Remember, multiply the numbers in front, add the exponents. X squared times 5x is 5x to the third. X squared times negative 3 is negative 3x squared. And I'm done with this one. 3x times 2x squared, 6x squared. 6x cubed, I apologize. 3x times 5x is 15x squared. You can see these get long the more terms you have. And 3x times negative 3 is negative 9x. Done with that one. One more to go. We're going to race to the finish here. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 5x is negative 5x. And negative 1 times negative 3 is 3. So again, I'm ready to clean it up a little bit, gather up my like terms. I've got 2x to the fourth. Powers of 3, I've got a 5 and a 6. Looks like that's it. So that's 11x to the third. Powers of 2, I have -3, 15, and -2, so that would give me 10. And I'm done with those. And then the x's, I have -9, -5. And finally, I end with my constant on the end. And that's multiplying polynomials.